Hey, welcome to part 8 of the Parabolas section. In this part, we're going to do a few examples of sketching some parabolas. So, first example is going to be y equals x minus 3 times x plus 1. Notice that another way to write this is x minus 3 times x minus negative 1, because two negatives make a positive. So these two guys right here, negative, negative is positive. So why did I do that? Well, the reason why it's easier to write it in that form is because we get 2 points on which the graph goes through for free. Because we know that if we stick x equals 3 into there, we're going to have 3 minus 3 equals 0. So we know that when x is equal to 3, y is equal to 0. And hence our parabola goes through the point right there. X equals 3, y equals 0. Similarly, when x equals negative 1, if we put negative 1 into the function, that part's going to be 0. So we'll have negative 1 minus 3 times negative 1 minus negative 1. Well, negative 1 minus negative 1 is 0. So we got negative 1 minus 3 times 0, and that's still 0. So we know that when x is equal to negative 1, y is equal to 0, and hence our parabola goes through this point here when x is equal to negative 1 and y is equal to 0. Well, that's two very good pieces of information, but there's a couple of other things we should know as well. Well, first of all, make the observation that when we expand this thing out, our first term is going to be x times x, well, that's x squared, plus some other stuff when we expand the rest of it out. But in particular, it's 1x squared, and 1 is greater than 0. It's positive, so our parabola is going to be that way up. If it was a negative something times x squared, we're going to be that way up. Recall that from the previous sections. So, almost, but last but not least, we know that parabolas are symmetric. We know they're symmetric. There's a line of symmetry right down the middle. Well, the point that's in the middle of negative 1 and 3 is actually 1. We can work this out by noting that the middle point is going to be the average of the two numbers, or the mean of the two numbers. So that's going to be negative 1 plus 3 divided by 2, and that's equal to 1. So our parabola is going to be symmetric about the line x equals 1, and hence to find the turning point, the lowest point that our parabola goes, we just need to put x equals 1 into our function. When we do that, we get y of 1 equals 1 minus 3 times 1 minus negative 1, while 1 minus 3 is negative 2, and 1 minus negative 1 is 2, because two negatives make a positive, so it's 1 plus 1. So it's going to be negative 2 times 2, and that's equal to negative 4. I might need to make this axis a bit longer. There we go. So negative 1, negative 2, negative 3, negative 4. So we know that our turning point, the lowest point that our parabola goes to, is going to be the point where x equals 1, y equals negative 4. So that's that point right there. And if we really want to be extra detailed, we can work out the y-intercept as well. Where does our parabola go through the y-axis? And, well, when it goes through the y-axis, for all of the values on the y-axis, our x-coordinate is 0. And so to find where the y-intercept is, we put x equals 0 into our parabola, into our function. And so when we put x equals 0 in, we get y of 0 equals 0 minus 3 times 0 plus 1, and that's equal to negative 3 times 1, which is equal to negative 3. And hence our y-intercept is when y is equal to negative 3. So that's that point right there. And that's about as much detailed as we need to be when we're sketching a parabola. We don't have to draw it with extreme accuracy, just have to get a pretty good idea of what it looks like. If we want extreme accuracy, we can do it on computer. Or we can plot a lot more points if we're doing that by hand. Okay, so that's what our parabola looks like. Let's do kind of one more example out of this. Let's suppose now that instead our parabola was the same except, oops, no, I don't want to clear. The same except instead of x minus 3, we had 3 minus x. Oops, 3 minus x times x plus 1. Well, 3 minus x is actually the same as negative 1 times x minus 3. So negative x minus 3 times x plus 1. If you don't believe me, try it out. Expand that part out for yourself. It's going to be negative times x, that's negative x, and negative times negative 3, well, that's negative negative 3, which is 3. So yeah, those two things are equal to each other. And so it's actually the same as this function here, except this negative sign flips the whole thing upside down. So if we're going to draw this, it's actually going to look like this. It's going to look exactly the same, except it's going to be flipped upside down. So we flip this thing upside down. So it's going to go through these 2 points still, but it's going to be a mirror image along the x-axis, because all of a sudden all the negative y values will be positive because we're timesing them by negative 1, and all positive y values will be negative. So our function, our parabola, the graph of our function, is going to look like this. Hopefully I've drawn that right, drawn that properly. Well, this point here has to be 3, y equals 3, because on our other graph it went through y equals negative 3 and x equals 0. And also our turning point, this time when our parabola reaches its highest value, has got to be 4, because our other parabola reached its lowest value when x was equal to negative 4. Okay, that's enough for this example. I'll do some more examples in the next section, in the next part, sorry. Until then, take care. Bye.